This video is over properties. So before we look at that, let's look at our number routine of fix a mistake. Gail says 4 times the sum of m and 5 is written as this, 4m plus 5. Is she correct? So let me get my pen. I don't know if she is correct. It says 4 times the sum of m and 5. Remember, in order of operation, we highlight this, the operator, the left term is 4 times m, and the right term is 5. So it's 4 times m plus 5. This says we do 4 times the sum of m and 5. I mean, we need to add the sum of m and 5. But we make sure we put a parentheses around it to show that this is 4 times the group or the sum of m plus 5. So Gail is not correct. Now, an electrician charges $25 to visit a house plus $60 for every hour of work. Define a variable and write an expression to represent the total cost of hiring an electrician. Concerning missing information, they didn't tell us how many hours this electrician worked. So that must be the thing. So let H equal the number of hour of work. So electrician charges $25 to visit a house plus $60 for every hour work. So in 1 hour, you pay $60. In 2 hours, you pay $120. In 3 hours, you pay $180. So it must be times the number of hours. So $60 times the number of hours. It could be also written as 25 plus 60 times H, or 25 plus 60H. I'll even take this, 60H plus 25. Today, using properties, you're going to realize that this is equivalent to this. So if you are going to be doing a gallery walk in class, you'll be given a sticky note, and then you're going to explain your reasoning as to which expressions are equivalent and are not. So which of these expressions are equivalent? Explain your reasoning. So you have first, second, third, and fourth. You have an addition, a multiplication, a subtraction, and a division. Which of these do you think will be equivalent? Well, let's look at the first one. If I substitute or replace the x with 5, that'll be 5 plus 20. This will be 20 plus 5. Are they both going to be equivalent to 25? So yes, this is equivalent. What about the second one? 20, I substitute the x or evaluate the x with a 5, that'll be 100. And 5 times 20, that also be 100. So yes, that would be equivalent also. So addition and multiplication. You add or multiply. It does not matter which way you add or multiply. You can add the first term to the second term, or the second term to the first term, and it will still be equivalent. Or when you multiply the first and second term, and multiply the second and first term, they'll still be equivalent. But what about subtraction and division? 5 minus 20 and 20 minus 5. Well, that will be equivalent to 15. I know for positive, for sure, I mean, a 5 minus 20. Add the opposite, that would be negative 15. No, that is not equivalent. What about division? 20 divided by 5 is 4. 4 divided by 20, which is 2/10 or 1/5. Wait, 4 which is 2/10, 1/5. Oh, I need to go redo that. They are not equivalent. So no. So when you add or multiply, it does not matter about the terms, but when you subtract and divide, it does matter. Next one. Which of these statements are which expressions are equivalent? Explain your reasoning. So yeah, we're adding with 8 plus 4. Oh, I'm going to highlight these because remember, in order operation, you, you highlight the operators of addition and subtraction. So on the left term, we have 12, and the right term is 2. So it is 12 plus 2 is 14. I replace this x associated 8 with 8. So the left term is 8, the right term is 6. It is 14. So yes, this is equivalent. What about the second one? I replace the x with 8 and 8. The left term would be 4, the term would be 2, so it's 2. In this one, the left term would be 8, the right term would be 2. 8 minus 2 is 3. No. Hey, just like the other one, you're adding, it doesn't matter the first, second, or third term, they will always be equivalent. But we subtract, it does matter. Order does matter. What about multiply? Want to make a prediction? When you multiply, doesn't matter where the terms are. Will it be equivalent or not? I say yes, they are equivalent. I'm making a prediction right now. 8, substitute 8. 8 times 4 is 32. 32 times 2 is 64. 8 times the product of 8 is 64. So yes, they are equivalent. What about the last one? I'm going to make a prediction that division will be no, because I think order does matter. 8 divided by 4 is 2. Divided by 2 is what? This one? We substitute the x with 8. 8 divided by, what is the quotient of 4 divided by 2? 2. 8 divided by 2 is 4. So, as you can tell, they are not equivalent. So, when you add and subtract, order does not matter because it does not matter where the terms are. Let me say it over again. When you add or when you do adding or multiplying, order doesn't matter because it does not matter where the terms are. Because when you add, they will all be equivalent. And when you multiply, it will all be equivalent. Now let's look at our last examples of equivalent expressions. You have 4 positives, you're adding 4 negatives. Well, that equals 0. Think of 0 pairs. Do they cancel each other out? Yes, that will be equivalent. How about this? 4 times 1/4 and 1. That's like being the reciprocal of 4. With 4 times the reciprocal will equal 1. Let's see. We write 4 as a fraction. 4 over 4. Yes, it is. What about the third one? -6. You add 6 more negatives to it. Well, that equals 0. And 3/4 times 3/4 is 1 whole. No, it's not. It's 9 over 16. No, they forgot to do the reciprocal here. And to get 0, they needed to do the, they had to add -6 to 6. So what we've been talking about now are called properties. The property that we're going to really focus is commutative, associative, and inverse. In commutative, we just saw it. It's 5 times 3 is equivalent to 3 times 5, and 2 plus 5 is equivalent to 5 plus 2. No matter where the terms are, when you multiply and add, they will be equivalent. It's the same thing with associative. No matter where you're adding 3 numbers together or multiplying 3 numbers, no matter where the terms are, they will be equivalent. It does not work for subtracting and dividing. Inverse, you're going to be hearing us do, we have been doing inverse. We may not use the words throughout the year, but inverse is negates, does the opposite effect. For example, if you add 5 to -5, what happens? You add 5 to -5, we get 0 pairs, so they cancel out. And what about 6? If you do the reciprocal of 6, that's 1/6. And then that becomes 1 whole. So it negates, cancel things out. And identity, we don't sorry, but identity is you multiply by 1 or add 0, 5 times 1. Anything times 1 will become the same answer. If you add 0 to any number, it will still become the same answer. Like nothing changes. So those are the properties. The main thing I want you to focus on is I don't care if you know the property names, because that's more when you get into algebra, you will have to know property names and its usage. In sixth grade, we focus on given the two expressions, are they equivalent or not? So using what you know about expressions, if it's adding or multiplying, no matter where the terms are, they will be the same. For example, 3 plus 4. Is that equivalent to 4 plus 3? Yes, because if I replace these with, example, replace these with 5, they'll both be equivalent to 9. What about 5 times y and y times 5? Are they equivalent? Yes, they are. If I replace the y's with 10, this will be 50, this will be 50. They are equivalent.